Hello everyone, this is our group's final project demo, which is an HRAP, an HRIS analysis platform. The members of this group are Hongmin Kai, Li Dongjing, and me, Gao Richen. Previously, in a data mining course, we applied PCA, K-means, and one-hot encoding to do data analysis. Later, in people analytics, we work with Excel and MySQL. And now in database system, we are able to integrate MySQL and MongoDB with Flask app. So we decided to combine these skills to build a web system to visualize personal data and turn our learning into a practical project. So through this project, we want to solve this problem. The HR department usually needs much time to deal with the problems of organizing and analyzing data, and the results of that may not always be correct. So how will we solve this problem? For the front end, we will use Flask and PCA and K-means analysis to create an analysis platform. And for the back end, we want to also use Flask to support employee data entry with CRUD. For the database, we decided to use MySQL because it can securely store sensitive information like the employees' names and their birthdays. So for the CRUD part, we will be able to insert data of the employee, status, department, and their salary. And of course, we can update the employee's data or delete it. As for the data analysis dashboard, we will be doing data analysis using PCA, K-means, and one-hot encoding, and we will also have a cluster table. Alright, let's now demonstrate our HRAP platform. You can see here we have the employee list of 50 employees that we have through a different database. So let's first add a new employee. Date of birth and for status, we have permanent, probation, LTA, temporary, or external. And let's set the hire date. Down here, we will be able to input their base salary and their bonus as well. Alright, we've now added a new employee to the list. So we can see here, this is the new employee that we've added. Now we can start an analysis by clicking this button right here, which will lead us to the group analysis report. Now, first of all, we have a cluster summary, which gives a general idea on the clusters that we have through the K-means analysis. We have 4 different clusters here of varying size. And down here, we have the clustering insights with 4 different types of people within the company. We have the interns and contingent staff on cluster 0, the mid-level specialists on cluster 1, the senior core and leadership on cluster 2, and the junior associates on cluster 3. And down here we have the predictive analysis and analytics dashboard, which shows the turnover risk and salary assignment of the employees. Down here will be a detailed classification list of which employees are very likely to quit. So we have 17 high-risk employees here, and then we have the 8 more at medium risk and the rest at low risk. And then we have the salary alignment, which you can see we have 13 employees below the standard market. On the bottom here will be a detailed group list for each employee and which cluster they belong to. So you can see here we have all 51 employees, and a recent one that we just added would be around here.
And then let's take a look at our 4 tables we made in the MySQL. And the first table is employee, and you can see the design of our column in employee table. And this one is department table, and the salary table, and finally is status table. And this is the ER model of our full table and shows the relation of this full table. Like status ID, the primary key is in status table, and in the employees table, we use status ID's foreign key. And in the employees tables, we have employee ID primary key, and we use employee ID in the salary table. And in the departments table, we have department ID's primary key, and we use it as salary tables and employees table. And then let's take a look in our code of our project. And let's start with app.py. And okay, we start by configuring the database connection. We used an F string to securely inject a credential from a separate config file, and then initialize the SQL Alchemy ORM. And then in the class, this is a for table, and in class employee here, we define the employee model and know the DB relationship, and they allow us to access related departments and salary data directly as Python object without writing raw SQL queries. And in the full name here, and in the index rules, we handle the search functionality, and we use funconcat to combine names, allowing user to search by first name, last name, and or full name in a single query. Okay, and in the add transaction, add, and here, new employee. And for the add rules, we use a transactional approach. We create both the employee and salary object and commit them together, ensuring we never have an employee record without salary data. Okay, and in the edit rules, and we handle updates carefully. The logic check if a salary record exists. If it doesn't, it creates a new one automatically or prevents database errors. Okay, and in the analysis route here. Okay, finally the analysis rules connect everything. It triggers our external analysis model to process the data and pass the results to the front-end templates for display. Okay, and this is app.py. And then let's take a look at analysis.py. Okay, and first, and here, we first execute a complex SQL join query, and we load this directly into a pandas data frame to get a complete view of employees' departments and compensation. And here we then perform feature engineering. We calculate age and tenure from the raw data columns to provide a machine learning model with numerical data it can understand. Then, since algorithm can't process text, and we use get dummies, this performs one hot code encoding, converting categorical variable like gender and department into binary numerical columns. And here, we apply the standard scalar. This normalize the data, ensuring the large figure like salary don't overpower a smaller but important number like age. And then PCA. We use PCA to reduce dimensionality, and we set it to retain 90% of the variance and keeping the most important patterns while discarding noises. Finally, we run the k-means algorithm with 4 clusters. This automatically groups employees into distinct segments based on their career patterns and salary data. Okay, and Then let's move into the add employee list. And first, this script automates our front-end updates. It reads the existing HTML template and locates the specific marker comment to find exactly where to insert the new code. Okay, and we defined a multi-line string containing the HTML for a bootstrap accordion. This structure organized complex data into extensible and easy to read section. And here inside this string, we aimed Jinja 2 logic. Notice the for loop and the critical if statements, and this ensure that only employee identified high risk appear in the high risk alerts section. Okay, and we also use Jinja filters to calculate counts and dynamically, and this line automatically counts how many employees are below market and salary, giving HR an instant summary. Okay, and finally, the script replaces a marker with our generated code and writes it back to the file. And this ensures our visualization is always perfectly synced and with the backend logic. Okay, and this is add employee list apply.
Now, let's talk about why we choose random forest as our model. First, it handles complex patterns. Human behavior isn't a straight line. This model can easily learn complex relationships, such as how turnover risks changes with years of service, which simpler models miss. Second, it is stable on small data. Since our dataset is limited, complex models like neural networks can easily fail by just memorizing the data, which is overfitting. And random forest uses a voting system to ensure the predictions are stable and reliable. And third, it is not a black box. The model clearly ranks which factors are most important. It tells us exactly why prediction is made. For example, salary vs tenure allows us to verify the results with HR logic. Now, I'm going to talk about how I make the models. So we can look here in the train models.py. We first import pandas, pickle, OS, and other like scikit-learn. And next we create the database connection. And we select the features we want to join. And for the feature engineering, we have like date of birth, hiring date, age, tenure, and total compensation is base salary plus bonus. And we want to train the random forest model. So first, we have some if-else statement for ground truth. For example, when tenure is below 3 and total compensation is below 40,000, it returns high risks. And next, for reinforce our feature engineering, we just keep our most important feature. And some of it, we add some ratio for training. And next, we encode the categorical variables. And next is we simplify the feature set. And we split data in 80% and 20%. And next, we have the random forest classifier and grid search CV.
for finding the most effective one. And we use cross validation score to see which is the best. And next, we have the reports of the when we classify. And we also will print the top 5 important features. And for training the salary predict model, we also did like split data and also have the train random forest regressor. And we evaluate by having MAE and R square for it. And we save the model for into a pickle file. And we also have like encoders pickle file also for the models. And this is the train models.py. And now let's see the prediction.py. So because we don't want our website to train the models again and again when we open it. So this file's purpose is we use the pre-trained models for showing the data on the website. So we will load the models to see if it is this or not. And next, we will get the prediction results by loading the employee data. And here, this is the same as the train models.py, is the feature engineering. And so basically here is the same as the train models.py. Yeah. And we did some, we will show if the employee is high risk or low risk or not. And this is like the salary part. And we also just use the pre-trained model. And we will align the results and having the overall detailed report. And here for insert prediction.py, we want to insert prediction result into our website. So we will use marker to find the insertion point after clustering inside section and before the detail list. So this is the explanation for making the random forest model. After we did the model predictions and insert back to our website, we find these results. First, 1 in 3 employees is at high risk of leaving. And second, salary decisions lack logic, appearing unstructured. And therefore, the company faces a critical retention issue. And the root causes of this is the turnover is driven by unfair pay gaps compared to peers. And a quarter of our staff receives salaries below market rates. And the direct link of this is this underpaid group matches our high-risk turnover list. And we can see the danger zone, which is the employee with less than 3 years of service are most likely to leave. And salary growth is not competitive during these early years. And the approaching risk is competitors can easily attract our undervalued junior talent. Therefore, we have the action 1, triage, which we focus on the 16 employees who are both high risk and underpaid, and initiate salary adjustments before they resign. And for cost efficiency, we can see that retention is cheaper than the high cost of replacement. And action 2 is reform, is standardize. Implement standard salary bands to ensure consistency. and freeze raises, halt increases for the 10% currently paid above market, and reallocate, use saved funds to correct the salaries of underpaid staff. And the outcome of this is for data-driven HR, which move from guesswork to accurate predictions, which is 90% of the random forest model, and objective based compensation on market data, not subjective feelings, and results achieve a stable workforce and optimize budget control. This is our task distribution. And thank you for your listening.